Saxon Algebra 1, lesson 118, second lesson of the final week. Yay. Students, the next two lessons, 118 and 119, are going to be super important, very meaty lessons that we're going to spend a ton of time working on next year. John is rolling them across your path here at the very end of Algebra 1 so that next year in Algebra 2, when they roll back across your path, then you'll look at them and go, oh, I kind of remember this. That's all we're going for. We're just trying to plant some seeds in your brain, John and I, and create that moment that you'll have next year of going, yeah, I know a little something about this. I don't totally get it, but I kind of get it. And that will be a glorious moment, and it will make it much easier for you to learn more fully and completely next year. So we're tossing this at you. It's going to be hard, but that's okay. You're both up for it. And then next year, we'll come back and we'll see it again and we'll talk some more. Okay. This is a trinomial, right? Sometimes we write equals 0. Sometimes we don't. And you guys know how to factor it. It's using a technique that we call by inspection, which is to say you just look at this and you figure out, you know the clue, two numbers that multiply to this and add to this. And you know it's going to be like this, and you know there's going to be x's here, and then you look at this and you think and you figure it out. I'll give you a second to browse. And then you can go, oh yeah, okay, I get it. It's -5 and -2. And then if it says equals 0, you can go on and solve it. I don't need to show you that. But this is called by inspection. And it is one of the ways to factor I ran out of room, trinomial, which is what that is. That's what we've been doing. Today we're going to learn a second method to factor a trinomial, and next lesson we're going to learn the third way. Okay, this is called by completing the square. Thus the title of today's lesson. And then this is called by the quadratic formula. All right, so this is today, lesson 118, and this is lesson 119. We've been doing this a ton this year, right? This inspection thing where you look and you find the numbers. And then next year we'll still do some of this next year, but we'll be doing lots more of these. All right. This is a very long, complicated process with lots of steps. I personally love it, but then I've been doing it for a really long time. But I think it's fun. I'm just going to tell you that what happened is that mathematicians back in the day got really sick of all of these steps of completing the square. So that's why they decided, you know what, let's just come up with a formula that will allow us to jump right into the answer without having to remember all of these bloody steps. So if you get annoyed by this big, long process I'm about to show you, just remember the great mathematicians of, I think it was like the 1600s, 1700s maybe. They were annoyed too, and they decided to find a solution to it. So you won't have to do it forever, but this is a great algebraic skill that we're going to use in other problems too. Okay, enough build up. 118.1. Ready? Solve this thing by completing the square. Okay, so John gives us this. Okay, so right away we can see, oh, he's being dramatic. He's being so dramatic because he didn't give us this in the proper arrangement, right? Normally we like it like this. This is the standard form of a quadratic equation, or what we call a trinomial, right, equation. This should be over here in the middle because it's the x term. So we're going to swim this. Remember, we can always change sides quickly by remembering the rule that says if you change sides, you have to change signs. So I'm going to make this x squared plus 10x plus 6 equals 0. Okay, now we've got a great start. So our step number 1 is, I'm calling that reshaping. Reshape to standard form. Okay? Sometimes you don't have to do that. Sometimes John is a drama princess and we have to do it. Number 2, kick C to the curb. Okay, what I mean by that is, see how C is the plane number at the end? We're going to kick him to the other side. Later, we're going to learn to do another version of this kind of problem, and this will make more sense. And when we get to this, I will say to you, okay, remember when I told you kick it to the curb instead of telling you to swim it? This is why. And so put that in your brain. There will be a day when I'll explain this. But we're going to kick him to the curb, and that means move him over. So now we have x squared plus 10x, leave a gap. Okay, so see how I get 0 there? Don't leave the empty space there because that's going to help you. We get minus 6 over there. 3, find the magic number. Oh, yes, I did. Say the magic number. We're going to find the number that we can put right here that will turn this part of the equation into a perfect square, thus completing the square. All right, let me tell you how to find the magic number. We take the number b. B is the number in front of the plain x term, right? That's kind of messy. In this case, it is 10. We divide it by 2, and then we square it, okay? That's the formula for the magic number. B divided by 2, and then that number squared. Later, we'll use a different version of this, b times 1/2 divided by 2. You don't need to remember this one now. This will become better when we have b's that are fractions, all right? But right now, John's not giving us that much drama. But this is the, this is just, as you see, b over 2 is the same thing as b times 1/2. But this is helpful when b is a fraction. Okay, I said too many words. 10 divided by 2 squared. Now, I always want you to write this out, and I want you to put a number, an arrow to the numbers inside the parentheses. They are very important, okay? They're not the magic number, but they're going to come in handy later. This is 5 divided by 2, which is 25. Our magic number is 25. We need to add to both sides. The magic number will always be positive because we're squaring. B could be negative, and this number inside the parentheses, that could be negative, but when we square it, we'll always get a positive. So I'm going to add, and that's this little gap that I created, that's what reminds me, oh yeah, I need to fill it in with the magic number. 25, and I'm going to add 25 there. Now, don't worry about the right side. That's easy. We'll figure it out later. What we've done here by creating this magic number and throwing him into that gap, we've created what's called a perfect square, which means we can factor this now just the way we did when we factored by inspection. We look for a number that multiplies to 5 and adds to 10. And this time it's always going to be the same number. Okay, we don't have to think of two numbers, just one. And we can say this number is 5. Right? 5 times 5 is 25. 5 plus 5 is 10. I found it. Now we're going to rewrite that as x plus 5 quantity squared because I've got it twice, so I can write it like that. All right? The other way I can get that, figure out what number goes here, is it's always going to be this number right here. That's why we drew the arrow to it. Okay? So the number that we want in our perfect square is not the magic number, but it's the number inside of there. That's just the way it works out. We can calculate it independently if we want to, and it's a really good idea to check it. But right there, we can just take it out of our magic number calculation and know that that's the perfect square. Okay? And then we want to write it like this. Now, I need to put those two guys together. In the meantime, that's 19, right? Okay, now we've solved things like this before. John was getting ready he was getting us ready. Step 4 is take the square root of both sides. We're squaring this and we don't want to. We always want to set our x free. So what we're going to do is we're going to take the square root of both sides to cancel those two out, right? The square is canceled out by the square root. So now we'll have x plus 5 equals, and we need to do plus and minus square root of 19. We've practiced this before too, haven't we? When you take the square root of something, you want to consider both the positive and the negative roots. All right, and then we're just about done. 5, we just want to do algebra to solve. So we'll subtract 5 from both sides. And it's okay if you just want to jump that over. You don't have to show that step. X equals minus 5 plus or minus the square root of 19. This is the number that's equivalent to those numbers up there. Now you understand why we couldn't just look at that, because I can't see minus 5 plus the square root of 19 in my head when I just look at something like that. I could have never guessed, right? That's why we need to know how to complete the square. Completing the square works for any quadratic expression, trinomial, if you prefer to call it that. Factoring by inspection only works when the numbers are cute. All right? That's why completing the square is so important, because it always works. That's why I'm putting an asterisk by it. Also, the quadratic formula always works. These guys are tried and true. Factoring by inspection, you just have to pray it all works out. All right, that was the right answer. Good, I put a smiley by it. Let's do another one. We're doing a total of 3. So, 1 down, 2 to go. I'm having fun, are you? Oh my gosh, I just love this, you guys. All right, I hope you got those notes down. Go back and copy if you didn't, because it's a lot to remember. It is a lot to remember. Okay, ready? Complete the square to solve. Once again, John is being dramatic. He gave us a scrambled mess. We always want to get it into that pretty standard form. You know how to do that. So it's going to be x squared. I'll make that a plus 5x plus 3 equals 0. Okay, step 1. Kick C to the curb. Remember, this is A, this is B, this is C. Goodbye. X squared plus 5x. We'll subtract 3. This cancels, but I'm leaving the gap there. That's the minus 3. What the heck? What am I going to do with that gap? Oh yeah, magic number. This is how I would show it in my homework if I was a student. This is how I'll do it from now on. Magic number calculation. I'll show you the formula again. I won't do that forever. B over 2 quantity squared. We need the parentheses to show that you square the B, but you also square the 2, right? You take the square root of the whole fraction. The square of the whole fraction. And then we want this number. That's going to be helpful to us later. In our case, this is 5 over 2 quantity squared. Our magic number just turned into a fairly hideous fraction, didn't it? Because what we have to do is we have to take 5 over 2 and we have to square top and bottom. So it's going to be plus, it's always positive, 25 over 4. Good Lord. And then we'll do the same thing here, right? To keep it in balance. 25 over 4. That's disgusting, but it's okay. It's okay. Those fractions really don't hurt us. They just kind of make things messy. Now we're going to write this as a perfect square. And I could study this fraction to figure out what number goes in here. Or I can just look over here and go, oh, it's 5 halves. It's always the number inside the parentheses. All right? So there's my perfect square. Let's double check it. These should multiply together to get this. 5 times 5 is 25. 2 times 2 is 4. They should add together to get this. 5 halves plus 5 halves would be 10 halves. 10 over 2 equals 5. It works. It should always work, you guys. And I do heartily recommend that you check it because it's so easy to make mistakes. Now we can just write it like this because for algebra's sake, that's going to make it easier to solve. After we've been doing these for a while, you can skip this step and go right to this. But for now, I want you to write out this step to make sure that you understand. All right, so this is the factoring of this expression. We factor this by inspection, and then we rewrite the same thing using the squared format instead of writing them out separately. All right, what's going on over here on the right? This is a mess. And we have to add -3 and 25 over 4. Well, I think we need to multiply this so the denominators match, don't you? Can you imagine we're doing all this really hard math, but we still are worrying about these ridiculous denominators. All right, it's a 4, so I better multiply this one by 4 over 4. So I'm going to write this down here. It's going to be -12 over 4 plus 25. Woo, my 5 went crazy, over 4. So that's going to be 13 over 4. Make sense? All right, now we take a break, look out the window, and go, oh my gosh, why must I? Why is life so hard? I know, but it's okay. All right, now this is the glaring, ugly part. So we go, oh yeah, let's pig house that bad boy and get rid of it. We'll get x plus 5 over 2 equals, and we just have to always remember that plus or minus. And notice this I can rewrite as square root of 13 over 2. I can set that pair of two pigs free, can't I? And here's the thing, because of the way we build these numbers, you'll always be able to simplify the denominator to come out to a cute little number. Okay, that'll always work. So we'll have square root of 13 over 2, right? Let's just simplify it right away. All right, and now we've got all the hard, ugly part done. Make sure you see that in there. Super important. We practiced this in an earlier lesson, but just know that whenever you're completing the square, you always want to see that, right? We want to see this radical, then we're going to make it go away. We want to see this, and then our last step is to swim that over. I'm going to do it the quick way. Change sides, change signs. It'll be -5 over 2 plus or minus the square root of 13 over 2. And that is the way we want to write it. Some mathematicians would write it like this, right? Because these denominators match, they might squish that together into one fraction. John and I agree on this. We both say no, don't do this. Later, next year, we'll talk about why we don't want to do it like this. I mean, we do want to do it like this. We don't want to squish it into one. We want to leave them as two separate. There's a reason why. I'm not going to bore you with it now, but leave them as two separate fractions. All right, this is 118.2. We have one more. Are you ready? There will definitely 100% be a problem on the final. The final is just another midterm. It's not any different. It's not like it's different in some way because it's a final, but we just call it the final because it's the end of the year. And this lesson will definitely be on it. Okay, so make sure that you are either understanding this or asking me lots of questions because I want you to get this right. Complete the square to solve. Ready? X squared plus 1 equals 3x. Well, John's having a bad day because he cannot get his quadratic equations into proper form to save his soul. So let's help him. X squared plus 3x. Oh, no, it's minus, right? Because I changed sides, change sign. Plus 1 equals 0. Okay, let's kick that 1 to the curb. We have x squared plus 3x. That cancels. Oh, leave the gap. equals minus 1. But why do we have the gap there? Oh, yeah, because we have a magic number. Our magic number is, oh, I'm sorry. I'm having a hard time. This is how mistakes happen. That's a minus 3x. It's b over 2 quantity squared. So ours is minus 3 over 2. I want that minus sign in there because I'm going to need it when I write the perfect square. But to find the magic number, we have to square it, and that will always be positive. So I want to add, let's see, that would be 9 over 4, right? And it would be positive 9. So it's going to be positive 9 over 4. And this will add positive 9 over 4. Okay? We've got the magic number. Remember, you have to do it to both sides. I got a problem wrong when I was in this class, Algebra 1. Mr. Herrick was my teacher. And I forgot to add to the other side. Ugh, so maddening. Okay, but I'm over it now. Okay, so now we're ready to create our perfect score. Again, our perfect square. What multiplies to this and adds to that? I mean, it's hard to see, but there it is right there. We know what to put in. It's x minus 3 over 2 times itself, right? That's what the magic number did, was set this up to become the perfect square that it is, all right? So it isn't just a coincidence that it's turning out like this. That's exactly what we created. This number goes in there. Let's check and make sure. If I multiply minus 3 over 2 times minus 3 over 2, I get positive 9 over 4. Check. If I add them, I get minus 6 over 2, which equals minus 3. Check. Okay, so now that it's passed my test, I'm going to write it like this, right? Instead of writing both of them, I'm going to square it. It's going to make the algebra easier. These guys, I need to convert him with a 4 over 4, don't I? So it's going to be minus 4 over 4 plus 9 over 4. So that gives me 5 over 4. All right. Once you get the magic number settled in the perfect square, comfortable, you can breathe a sigh of relief, because that, I think, is the hardest part. Now we're ready to hit this square with a pig house. Oh, it's so satisfying. X minus 3 over 2 equals, don't forget the plus or minus, square root of 5, and remember that denominator will always come clean with a fraction. With a, it'll always come out of the radical, the pig house, right? He's trapped in here as a 4, but set the pigs free. All right, now our last step is the algebra. We're just going to swim that over. We get x equals positive 3 over 2 plus or minus square root of 5 over 2. Like I said last time, leave them as 2 separate guys. Don't smush them. Leave them separate and give yourself a smiley face. Yay! Lesson 118 is done. Now, I'm just going to remind you again. A, this will be on the test for sure. So make sure you get this down. And then next year, this is going to come up again. Somewhere around lesson 40. So it'll be Saxon Algebra 2, somewhere around lesson 40. So I'm not going to drown you with it as soon as we get started. We have lots of review to do next fall. But we'll come back to this and face it all over again, and you'll love it. Yay! We're done. Thank you. Goodbye.